Hello everyone, my name is Fahad and today I am presenting a review of recent advance in deep learning for object detection. In computer vision, image classification, object detection, intent segmentation and semantic segmentation found the most essential and challenging problem which aim to seek object locations from a greater part of predefined category in natural image. Image classification is the most important part of digital image analysis that can be affected by many factors. Its aim and object is to identify the features taking place in object in the image with a unique level in terms of color. In computer vision, main area for research is semantic segmentation. Basic theme of semantic segmentation is semantic segmentation for target object in a scene by using different color, then to apply semantic color labeling to each pixel in the image with semantic information. The object of object detection is to detect and trace effective target from image or video data. The identification of each object instance for every known object within image is known as instance segmentation. Traditional method of object detection. Traditional method of object detection. Proposal generation, feature vector extraction, and region classification are considered as traditional method of object detection. During proposal generation, region of insert or explore in an image the kernel are the best method for proposal generation. The feature vector extraction is the base of object recognition structure from the motion and other challenging problem in computer vision. Scale invariant feature and speed up the robust feature are the best methods for vector extraction. Region-based convolution networks are also suitable tools for accurate and efficient object detection, bagging, learning, and AdaBoost or some classification techniques that can be used in region classification for improving detection accuracy. Literature review, video analysis and logo detection. Image recognition problems have been encountered by the application of most powerful class of models known as convolution neural networks. Logo detection is a very challenging task in case of image due to its high labeling cost. For generation of synthetic context logo, training image top logo is the logo benchmark dataset with tremendous result. Object detection with neural networks learning system. A close relationship has been observed among the object detection, image understanding and video analysis. The recent advanced review in depth with the application of DCNN along with the architectures such as SSD, YOLO and faster RCNN to seek the current challenging met by the community in object detection and show that how object detection problem can be extended. Problem settings. For a detector, accurate localization and precise categorical label prediction are important factors for object from the background is an image. The inference speed and efficiency of a detector are important metrics to evaluate object detection algorithms in much accurate way. In object detection, softmax loss function and focal loss function have great impact on the performance. The quality of localization between object and predictors is determined by intersection error union. Frame per second are used for evaluation of efficiency of detectors. The speed of real-time detector is 20 fps. In object detection, map over C class is required evaluation of problem, but in real sense, the detection phase recognition and learning are used. Detection components two-stage object detectors. After inspiring by pyramids matching, the idea of SPP-net was suggested just to solve the problem RCNN and to accelerate the features of RCNN. It enabled to produce a fixed length output irrespective of size to an input. SPP-net can speed up equalization of object and extract information from various resolution, but its training scheme is still complex, slow and end-to-end training. SPP-net is little bit faster than RCNN. In the last few years, backbone architecture for SPP-net is VG16. Two-stage object detector, fast RCNN. It is proposed to overlap the section of RCNN and SPP, net such as detection accuracy and inference speed. It is composed of pooling with pyramidal level having specialized case of SPP layers. The processing of fast RCNN is very similar to SPP-net pipeline, only with minor modification. It permitted training of the convolution features extractors through back propagation. In last few years, backbone architectures for this detector is VG-VG16. Two-stage object detector, fast RCNN. It is proposed to overlap the section of RCNN and SPP net such as detection accuracy and inference speed. It is composed of pooling with parallel level having specialized case of SPP layers. The processing of fast RCNN is very similar to SPP net pipeline, only with minor modification. It permitted training of the convolution features extractors through back propagation. In last few years, backbone architectures for this detector is VG-VG16. Fast RCNN. The fastest RCNN was established to address these issues due to more accuracy and learned proposal. It relies on the regional proposal network, fully convolution and 10 times faster as the test time is fast RCNN trained end-to-end by applying features extraction, region proposal and classifier. In the last few years, backbone architecture used for this faster RCNN are VG16 and ResNet 101. One-stage object detector YOLO. This algorithm was developed in the year 2015 with the function of detection and recognition of objects in the picture in real time. Residual blocks, bounding box, regression, and IOU are the main techniques used in the algorithm. It is struggling for detection for close and small objects. YOLO V2 and YOLO V3 are the advanced forms of YOLO fastest with aim significant improvement in accuracy. In the last few years, backbone architectures for faster RCNN and VG16. Future directions. Scalable proposal generation strategy is challenging task in object detection. These have very high composition cost and can be effective in proposal generation strategy for future research. Effective encoding of contextual information is very crucial to the visual object detection and for better understanding the visual world. These are more precious in case of contextual information for object detection can be proposing for future research. Regarding image classification, detection of object via auto machine learning is of paramount importance and can be considered to explore in future. In the modern era, research lay on MS COCO as best detection benchmark, but the fact is that MS COCO have 80 categories, still small of for understanding more complicated scenes. Having 2-point high quality intense segmentation mask has been exposed an emerging benchmark dataset which is capable of simulating real-world low-shot scenario in the presence of rich categorical information. It will be more challenging in future. Laser research has been conducted so far on low-shot object detection. Low-shot transfer data detector was tested on animal and still affecting by overfitting. There is more question in this area to be explored in future. Concluding remarks. The main theme of this review is to provide comprehensive understanding to the research scholars about the contemporary advance in the field of deep learning, its technique, and application for the task of object detection in a more systematic way. Object detector components, learning strategy, applications, and benchmark evaluation are the main contents of this review. This review is indispensable for the future research to develop more strategy on the applicability and proficiency of deep learning techniques on the object detection.